In this video, we're going to be looking at acetals and ketals. We're going to be looking at their structures, the reagents used to form them from aldehydes and ketones, the mechanistic details, all the important stuff. So first of all, making acetals and ketals, you make them from aldehydes and ketones. So think about ketal as coming from a ketone, aldehydes coming, or acetals coming from an aldehyde. Now we make these using a catalyst, which I call PTOSH. So this is para-toluene sulfonic acid. Usually comes in a monohydrate form. I use this in my lab over the summer, as well as two equivalents of the alkoxide that you want to kind of add on. So the alcohol form of that, here we use two equivalents of ethanol, and this will form the acetal. So notice this H is the same as this H, and also this will generate water. So this is our acetal. And then for ketones, we can use the same reagents. So again, catalytic para-toluene sulfonic acid. I'll draw out the structure this time so you can see. So here's that toluene part. So para to the toluene, because the methyl is what makes it toluene, we have sulfonate. And it comes as a monohydrate, so we're just going to assume it to be protonated here. And this generates our ketal. Oh, side note. Those were supposed to be 2 carbon chains long. I have in my notes methoxide or methanol, but it's ethoxide. So this methyl is this methyl. Well, could really be either, but just because we're still using 2 equivalents of ethanol. And again, water is a byproduct. Ketal. So acetals and ketals, aldehydes and ketones. So we're going to look at now the mechanistic details of forming an acetal. I think an acetal is better to look at because you can see that H from the aldehyde follow along throughout. I just stole chalk from another room because I ran out of chalk in here. This chalk is actually terrible. Oh, this one's good. Okay. So here we have acetaldehyde, and we're going to react this with PTOSH and our 2 equivalents of ethanol. So para-toluene sulfonic acid is a very strong acid, so it's going to quantitatively protonate methanol enough so that we can say we have protonated like that. And the most basic site on this carbonyl is this oxygen up here, which will deprotonate so that we have this. Okay. And now with that methanol, or with that ethanol that we made, since this oxygen has a plus charge on it, this is a good place for that ethanol to attack, electrophile. So these is going to attack there. And we're going to get this. So now, with the other equivalent of ethanol that we have, we're going to deprotonate which will get us here. And also regenerate the catalyst. So now the catalyst is being regenerated in the middle. So we have now there, protonated ethanol. And this also has a name. It is a hemiacetal. Hemi, think hemisphere, half. It's half of an acetal, because this isn't ether. It's just an alcohol. So now we'll be able to protonate up here on this alcohol with our protonated ethanol, sorry. And we get, there's an OH2 group up there, basically a water group. And we can use the electrons from this oxygen down here to form a pi bond with this carbon and effectively kick out the water. So keeping things in perspective, that oxygen that we're just kicking off, or the water, but the oxygen from that water, is this oxygen here. So we've removed the original oxygen from the carbonyl. How much space do I have? Go up here a bit. Oh, broke the chalk. So now we have this. Okay, see how well you can see that. And we can basically do the same thing that we did back here, but instead of it being with a hydrogen, it has the ethyl group. But since we protonated this alcohol and kicked that off, we just have ethanol, which the ethanol can attack. Open that up. Now we're almost at our product. We just have to deprotonate with ethanol again, or really it could be with water. Okay. Hi, update a day later as I'm editing this. It's just a small mistake. I drew that ethanol to have 2 additional hydrogens on it. It just has 1. I made a pentavalent oxygen. It was just a drawing error. So we're just deprotonating there. And this gets us to our, acetal. So another quite steppy mechanism, but we got there eventually.